Hello. This video is to shed some light on the importance of removing pooled blood and how it affects the pressure demand. And when we talk about embalming, we're talking about introducing fluid from a single injection site. And by doing this, we will raise the pressure within the body to distribute fluid. But due to the circumstances or corpulence of the case, we may have pooled blood in certain areas where in other areas we don't. And this presents a disparity in fluid distribution because fluid always takes the path of less resistance. And popular opinion is that if we universally rise the pressure throughout the body enough, then fluid will be able to create enough back pressure to push the pooled blood out. However, that's not supported very well in physics or science because along this entire pathway of the arterial system, fluid can relieve itself already. So those are the pathways that fluid continues to travel. But no doubt, still we find many different ways to remove pooled blood, but they all lead us to a general focus known as the Venturi effect. And if we use pre-injections as a good example, pre-injections contain surfactants, which make the passage of fluid from arterial system to venous system much easier. So what this promotes is a ability to have a higher pressure inside the artery. And if we are able to move the fluid from the artery into the venous system, we can then have a greater volume of drainage from the venous system. And why is that important? What would the speed of drainage have to do with a good result? Well, the faster we can have fluid leave the venous system, well, the stronger the Venturi effect would be. The Venturi effect refers to a vacuum that occurs as fluid moves from point A to point B in our diagram there. And I'll do that again in red in case you can't see it. From A to B, we would have a strong vacuum at area C. A good example of this would be your hydroaspirator. Another example would be a train platform. This principle of science exists in many areas of our environment. So if we go back to our case here, the more drainage we have in this case, the stronger the vacuum would be on this pooled blood. Once that pooled blood is removed, it's no longer presenting a path of adversity. And so the pressure demand, the specific pressure demand in the area circled in green here is less, and so there'll be less disparity and fluid will have a easier means to travel. Hope you like this video. Use coupon code FREESHIP for any of our products, and like, share, subscribe.